Very good morning. Welcome you all to this NPTEL course on Economic Operation and Control of Power System. And today we'll be focusing on our lecture 2 on evolution of Indian power systems. As you have gone through the lecture 1, where we talked about the introduction and complete background of the course, today we'll be focusing on the evolution of Indian power industry. Now, if you go back as 1882, the first commercial DC power system set up at Pearl Street Station in Newark by Thomas Alva Edison to light 11,000 bulbs for 500 customers. And perhaps the operating voltage at that time was 110 volt DC and later on upgraded to 220 volt DC. And because of this, because the first electrification of a particular street was at 110 volt, or further it is 220 volt, but it was completely DC system. And hence the creator, Thomas Alva Edison, is known as father of DC distribution system. Now, but there was one challenge. Because of the low voltage, the current became very high for a given volt ampere transmission, so that led to high copper loss in underground cables, and that has limited DC power distribution to lower mountain area only. Means the project could not expand further because of its major losses. So Pearl Station also burned on January 2nd of 1890 and later decommissioned in 1895. Now, in the meantime, the transformer, which has been created by William Stanley in 1885, and also we came across induction machine, which is a AC machine, by Nikola Tesla in 1888. And those two devices is basically the turnaround of electricity system, where completely we converted from DC system to AC system. And also the voltage can be either upgraded to any value, and that may lead to reduction in current and hence losses. Nikola Tesla, now named as the father of alternating current. So please remember Thomas Alva Edison, who is father of direct current, and also Nikola Tesla, considered to be father of alternate current AC distribution system. Now, in 1889, the first single-phase AC system installed at Oregon City, and the power generation was from two 300 HP hydro generators and transmitted to Portland via 4 kV 21 kilometer transmission line. And the project was successful, and hence in 1891, first three-phase AC system installed in Germany for a length of 179 kilometer at 12 kV voltage level. Though initially there was no standard for frequency in three-phase power generation, so there's a lot of variation in frequency depending upon the laboratories. So people experimented from 25 Hertz to 133 Hertz. But today, as you all know, only 50 and 60 Hertz are considered to be prominent frequencies for operation. Now, interconnection and parallel operation of different power systems was not possible. So later on, the frequency was standardized. And as I told, that there are two frequency range operated today. One is 60 Hertz and the other one is 50 Hertz. So for North America, they operate with 60 Hertz, and the rest of the world operate with 50 Hertz. Now, let us focus a little bit on Indian power system. Now, July 24, 1879, the first DC power system installed in Calcutta by P.W. Florent Co. company, that is British administered company. And in 1896, the first hydro installation of 130 kilowatt in Darjeeling by Crompton & Co. And 1899, first thermal power station 1 megawatt in Imambagh, Kolkata by Calcutta Electricity Supply Company. Now, in 1948, after independence, we have introduced Electricity Supply Act, led to modernization in Indian power system. We have established both state electricity boards as well as central electricity authorities to regulate power generation, transmission, and distribution in each state as well as at different, at national level. So that means we have many state governed bodies as well as one national governed body. Now, 1975 is one of the remarkable year because Electricity Supply Act has been amended, where National Thermal Power Corporation (NTPC), National Hydroelectric Power Corporation (NHPC), Nuclear Power Corporation of India Limited (NPCIL) were established for the first time. 1989, the NTPC, which has been divided into multifold. First of all, NTPC, Operation of Control Owned Thermal Plants. So NTPC has been made the owner of all the thermal power plants. And however, the second part led to Power Grid Corporation of India Limited, so-called PGCIL, which is responsible for planning, operation, and maintenance of grid between the states. So if you see very closely, the generation and the transmission were divided into two different verticals. Now in 2003, Electricity Act superseded all previous acts. That means 2003 became a remarkable year which had nothing doing. Whatever the final version of the 2003 need to be acted upon by every individual of this nation. Now there we formed a new body known as Central Electricity Regulatory Commission (CERC), which has been formed for the first time. And then the PGCIL divided into PGCIL for planning and Power System Operation Corporation Limited (POSOCO) for operation of grid. So PGCIL further divided into two components. One is POSOCO and PGCIL for planning activity only. Now POSOCO started looking into the operation of the grid in real time. So if you see that way, 1991 we had an interesting scenario where we had 5 zones: northern, southern, eastern, western, and northeastern. So those zones started integrating, or interconnecting each other for a better operational activities. So in 1991, northern, eastern, northeastern, and eastern grid were interconnected. 2003, western grid interconnected with those northern as well as eastern grid, northeastern as well as eastern grid. Now in 2006, northern grid integrated with western, northeastern, and eastern. And 2013, after a lot of agitation, southern grid joined the northern, western, northeastern, and eastern grid. So that day in 2013, we started naming India as a one nation and one synchronous grid. That means everyone operates with the same frequency, all those 5 grids. Now then, if you look very much closely to the voltage levels, the generations, as I mentioned in my introduction section, it is 11.6 kV and 21 kV. Transmission, they are 1100, 765, 400, 220, 132, as well as HVDC with the plus or minus 500 as well as 800 kV. Sub-transmission distribution, they are at 33 kV, 11 kV, and single phase consumption with 415 3-phase and 240 single phase for the residential customers. Now, because of lot of renewable energy available in this nation, and they started generating, so we need to create a proper transmission of those power to the major grid. So Green Energy Corridor, which has been established. So the main objective of Green Energy Corridor project aim at synchronizing electricity produced from renewable sources such as solar and wind with conventional power station in the grid. Especially for evacuation of large-scale renewable energy, interstate transmission system, so-called INSTS project was sanctioned by ministry during the year 2015 and 16. Now, exactly, the government cleared a budget of close to 12,000 crores planned to set up infrastructure to transmit electricity from renewable energy projects, as it seeks to boost the output from green sources and meet half of the nation's energy requirement from them by 2030. It's an ambitious plan. Until unless you have proper grid integrated system which can evacuate all those energy available through renewable sources, it may not be possible to achieve your target in 2030. The investment approval by Cabinet Committee on Economic Affairs for the second phase of the Green Energy Corridor, which will help supply of 20 gigawatt of renewable energy to the national grid from Gujarat, Himachal Pradesh, Karnataka, Kerala, Tamil Nadu, and Uttar Pradesh for the second phase. Now, it will also involve approximately 10,750 circuit kilometer of transmission lines, 27,500 megavolt ampere transformation capacity. This will help to ensure huge injection of electricity into national grid from intermittent energy sources such as solar and wind does not threaten the grid anymore. The corridor also forms important component to keep frequency within the limit 49.9 to 50.05 hertz band. So that means the frequency cannot drop, less than 1, that is 49.9, less than 0.1, and also it cannot go beyond 0.05, that is 50.05. So there is a very strict boundary for frequency operation, which is 49.9 to 50.05. Now for that, an AGC, automatic generation control, recently made operational. We send signal to power plants every 4 seconds to maintain frequency, ensuring power grid reliability. The transmission system will be created over a period of 5 years and through 31 March 2026 as expected completion date. Now the first phase of Green Corridor is under various stages of implementation in Andhra Pradesh, Gujarat, Himachal Pradesh, Karnataka, Madhya Pradesh, Maharashtra, Rajasthan and Tamil Nadu. It will supply around 24 gigawatt of renewable energy. The first phase will add 9,700 circuit kilometer transmission lines and 22,600 MVA capacity of substation at an estimated cost of 10,000 crores approximately. Now, where we are leading to, in November Summit 2021, the Prime Minister pledged to increase the country on fossil fuel power generation capacity to 500 gigawatt and which can meet close to 50% of its energy requirement from renewable sources by end of the decade. The CEA, Central Electricity Authority, estimate India's power requirement will rise to 817 gigawatt by 2030. Almost too much, okay? So further, the interest in India's green energy economy continue to grow with the sector receiving foreign direct investment of $7.25 billion from 2014 to 15 up to June 2021. And $797 million was received during only 1 year, 2020-21. Hence the future is green energy for sure that none of us can deny anymore. Now, how do we regulate? What are the administrative blocks that control the whole Indian power sector? Dear friends, I'm very much keen to emphasize here because all the textbooks that we study, most of the time, they are either focusing on North American power systems or European power system. It is good to know that. But in the meantime, it is also important to understand how a large power sector like India operates today. The architecture through which we function must be known to every power engineer of this country. Now, we do have a mechanism called, or a body, which is Ministry of Power, that deals with planning, policy formation, processing and implementation of projects, as well as it looks into the legislation in regards to power generation, transmission and distributions. Then we have one more body, which is PGCIL, Power Grid Corporation of India Limited, responsible for national and regional power transmission planning. Then we have one more important body, which is CEA, Central Electricity Authority, advises on matters related to national electricity policy, and formation of short-term and prospective plan for development of power systems. Then we move to CRC, Central Electricity Regulatory Commission, and State Electricity Regulatory Commission. Those regulates the tariff, formulates policies regarding subsidies, and promotion of efficient and environmental policies at central and state levels respectively. Then we move to transmission, state transmission as well as central transmission units, where development of efficient, coordinate and economical system of interstate and intrastate transmission line is possible through CTU and STUs. Now this is one diagram, though the letters are not very big actually, so you can zoom perhaps when you study at your room, and you can see the whole architecture of Indian power system. The central part, which is talks about central government, that is the Ministry of Power. All the components that I talked are being presented here, and then that interlinked to my state level. Okay, so the state and centers are integrated, and you can also see different state sectors. They are generation, transmission, distribution, and different distribution companies like BSS Rajdhani or maybe Tata Power. There are many distribution companies too. And then you have actually trading companies. They are also available. And you can see there is one corridor which is POSOCO, which is also there. And then you have state independent power producers, small power producers. And the right side you can see there is a SERC regulator. Power exchanges, there are two power exchanges in this country today. Those who carry out the tradings, that is, one is known as IEX, the other one is known as actually PXIL. There are two different power exchanges. Those who do business on power, actually, similar to your money exchange, they talk about power exchange. And we have a CRC, Central Electricity Regulatory Commission, and also we do take care of actually applied tribunals if there are some complication cases that need to be resolved. And moving slowly, you can see there is a center called CPRI, Central Power Research Institution, NPTI, and they basically do R&D as well as bit of training for power engineers. And then we have different authorities like your CA, Central Electricity Authorities, which really directly in contact with your central governments. Now you can also see different type of organizations where you have NTPC, NSPC, NIPCO, transmission like Power Grid, and then you have actually POSOCO, and then Finance Power Corporations, Rural Electrifications. So these are the bodies. So this is the only diagram which will make you clear how Indian power system operates today. Unfortunately, all the power segments or power sector management of the world is not same. Different countries operate with their own strategic planning and strategies. So this is the Indian power sector management. We must know it. Here I do wish to acknowledge Professor S.C. Srivastava, retired from IIT Kanpur, who has helped me to create this slide. Now moving to short-term transaction of electricity. So short-term transaction of electricity depends, how we create an agreement and how those energy can be procured through a market mechanism. So electricity transacted interstate through interstate trading mechanism, and that is directly by the distribution licenses. So different distribution company present in your state can procure power from a generation company through a trading mechanism and then supply to your local consumers. So power exchanges, that is Indian Energy Exchanges Limited, which is named as IEX, and Power Exchange India Limited, PXIL, and Deviation Settlement Mechanism, DSM. So these are the three bodies who always settle down your market in a very short term. Now, why do we go for short-term reports? Short-term reports are important because settling the market is very important. The consumers behave differently, the suppliers behave differently, the market behave differently. So we have to be very careful. Under no circumstances, the customers are not being, kind of given electricity or energy 24 hours a day. So that is the main objective, and hence to analyze the volume and price of the short-term transaction of electricity. Now what happens? Now let's say if you there is some commodity which is very important, like for example gold price. So the trading happens and the cost may go from 50,000 to 60,000, 70,000, doesn't matter. All right. So if you are comfortable, you can buy it. If you are not comfortable, you will not buy it. But electricity, if that happens from 100 rupees to 500 rupees, okay, for a particular hour, then it is very, because this is a must commodity for us to live. Okay, so we cannot, though we can encourage marketing or trading, but nevertheless we cannot allow it to grow to an extent so that it is not affordable and you cannot really have electricity because of money matters. So that is where actually the government comes to action and see to that everything is properly being managed. To assess the competition among the market players, we encourage competition, but also we make sure they do not exploit the whole market business because it is a must commodity. To analyze the effect of congestion on volume of electricity transacted through power exchanges. Now what happens, we have transmission system and they do have actually limited capabilities to carry the power. Now if a particular customer like to extract all the powers to the client because because of some business model, and the transmission line is not able to carry, so that lead to congestion, which is not acceptable. So business come the technology, they have to go together. To provide information on volume and price of renewable energy certificate RECs transacted through power exchanges. For an example, let's say there is a wind power park which is keep on generating electricity at a particular hour, but somehow actually there is no business model helping that power plant, so you are not ready to buy that power. Just for an example. So then what will happen? Those renewable energy being produced, because this fellow poor chap actually cannot store it, okay? So it is keep on generating. And if you do not get into the grid and being purchased or being acquired by someone, then the energy will be wasted. The gentleman has to derate its power plants to lower rating, which is not advisable, okay? So we need to help those intermittent nature of renewable energy producers also to survive in this competition. Now to disseminate all of the relevant market information, which is very, very important. Now this very clearly shows the different volumes of actually short-term transactions of electricity in India in the month of January 2022. You can see the magnitude, the volume power being actually transacted, and it's a very interesting, though the percentage is not very high, but we are happy that India do experience a wonderful market requirements, and you could see that the power being exchanged to the graph below, which talks about the bilateral transactions. Bilateral transaction means the two parties agree to have a fixed exchange of power for a given duration. So you can see the bilateral transactions, the green one, and this there is blue one, and then the green one is power exchange, and then you have the settlement DSM, which is in the red lines. Okay. But one thing is very clear, the component of trading today in India is not very significant. Most of them are fixed transactions because they are fixed consumers. And you can also see the percentage share of electricity transacted by trading licensing with different companies. And you could see that the percentage of trading that has been taken place in Indian market now. Now the price of electricity, which is very important, as you could see, the price is 1 rupee per kilowatt hour, which is minimum, and the maximum is rupees as high as 8. So that shows in a given day, the price can go 8 to 10 times higher. So that is sometimes risky. So you have to be very careful in encouraging market environment to electricity. This is one important thing where you can see the short-term transactions, how it has taken place. And then you can also see the volume and price of electricity in green term ahead market actually for different exchanges in the month of January. So that will also give you an idea that the cost, which is in the order of between 3 to 4 rupees. This gives an idea how the market takes place in this country. Now, what is the impact? Now, the issue here is the global demand of energy is expected to climb about 25% by 2040. Okay, so energies keep on increasing. The requirement of energy, no one can stop. Now, India contributes about 45% of world energy demand growth in 2040. Means there is an increase, no doubt about it. So whatever being increased in 2040, India will contribute 50%, close to 50% of the global demand. So we are the kind of huge energy demand in this country. So you should be well prepared. And India and China saw the largest increase, with each reaching more than 1 billion middle class citizens. So because of aspiring middle class wanted to have electric vehicles, air conditions, very comfort lighting systems, and everything. Okay, so to make a good life, we need electricity, that we cannot deny. India will grow strongly with its share of global GDP doubling in recent time. Now, What are those factors affect the performance of your electricity grid? Now, first of all, increasing demand of electricity, supply shortfall of electricity, and we need to reduce the losses, and we have to also reduce the peak demand requirements, and then integration of renewable energy to the main grid. So these are the factors we have to be taking care to make sure the performance of the existing grid improves a lot. Also, we need to have solution for global warming, effective use of electric vehicles, customer satisfaction. That is one important. That means we cannot afford to provide. We need to provide reliable electricity to all the customers. Okay, and overcoming difficulties in meter reading. First of all, millions of electric meters. Sometimes they are functional, non-functional, taking those readings. So we need to replace all those conventional meters by smart meters in recent time to come. So poor efficiency of conventional power generation system, because they have been established almost more than 50 years back, and their life is not in good condition. So probably the efficiency is going down. So that is also another challenge Indian government has to look into. Now, also one more important part is aging asset and lack of circuit capacities. So if you see the transformers, they are also equally, decade-old devices, and the power network design life need for replacements. The capacity cost of life for replacement will be very, very high. So because nobody really knows how expensive it is to replace your transmission corridors or the substations. They are very, very costly, and that is an asset for us. So it is always better to delay your investment, but nevertheless, we need to plan strategically to make sure all the aged devices are being replaced at a given point of time. Now, the security of the supply, which is certainly an issue in India, need of reliable electricity supply as more and more critical loads are connected. We cannot afford to have even 5 to 10 minutes energy delay supply systems or non-availability of electricity for hospitals and for data centers. So we have to make sure that 24 hours the electricity is available to us. One more interesting challenge is about thermal constraints. The transmission lines, they have some capacity. If you allow it to be overloaded, then probably they produce heat, and then those lines will melt and fall on the ground. So the transmission and distribution lines are almost at its limit in this country because of huge requirements of energy. So probably that is another area we need to focus to avoid, line to ground fault, or maybe melting of different lines, or maybe failure of different transmission distribution systems. And also reduction in life of equipments. I've already mentioned most of the devices in this country are not very new. So I think they need replacement, and replacement cost is really huge. So you have to do in a phased manner proper replacement of those devices. And also increasing incident of fault. Very frequently we see that different transmission corridors are facing faulty challenges. I think transmission systems are, to my understanding, it is as per the global standards in this country. No one can challenge. But about the distribution system, we have to focus more actually. Now, some of the recent concerns that we have realized that limited expansion of transmission network as compared to the generation expansion. The way generation is increasing, probably the transmission system has to increase in the same pace. Most of the existing conventional generation transmission as well as distribution systems are quite old. So we need to emphasize on combined expansion planning, and also we need to have enough reactive power, that is ancillary services, because bringing too much of renewable energy to the system, we are losing reactive power. Okay, so reactive power planning is another important area that we need to be focused on. And also we need to see to that how distribution losses need to be reduced majorly, and lack of dynamic data for health monitoring and control. So we need to monitor properly what are those areas actually we frequently face failures or faults. Now, increased concern towards vulnerability and resilience of the system under natural and man-made disasters. This country do face almost every year one disaster, especially in the coastal areas. So that spoils all our transmission distribution systems. So we have to be careful. And then growing environmental concern, that is also a very big challenge, renewable integrations, and poor customer participation in energy management system. Unfortunately, we need to educate our people not to use electricity if it is not needed, number one. Number two, If, for an example, a very basic example, I keep on telling, I'm reiterating today, if you have to charge your electric vehicle, then we need to see, though anytime you can charge in a day, you have the full ride, the cost is same, and but preferably it is always advisable to charge your electric vehicles or on your washing machines, depending, if you can delay the peak points to a off-peak hour, probably you are contributing to the nation's development. And also, there's a huge challenge for electricity demand, so we need to be more conservative, not consuming more electricity if it is not needed. Now, moving to power system operation, electric power system is a complex man-made system with several interconnected elements and spread over large geographical area. As you know, the generation, transformers, transmission, distribution, and loads. Classically, vertical integrated power system has moved towards deregulation today. In the past, we have generation, transmission, distribution systems, and the energy used to flow from generation to the consumers. But today it is not true. Today the energy is flowing from generation to consumers as well as from the consumer to the transmission systems. Similarly, previously the money used to flow from the consumer to the companies, okay, reverse. But today the money is flowing from both the directions, okay, from the consumer to generation system and generation system to consumers also. Now, several utilities own, control and operate different elements except transmission system, which is still owned by the regulated by the POSOCO and PGCIL. So rest of the systems are actually completely utility owned. Okay, transmission system has not been controlled by anybody excluding government of India, that is POSOCO and PGCIL, because we cannot afford to give those transmission corridors control to any individual as of now. Whereas the distribution companies and the generation companies, they are being owned by many people for management of their energy segments. Now, today we talk about the improved version of distribution system. So we all realize that the distribution system need to be made smarter. The main reason being availability of energy sources, which was not there in the past within the distribution system. And then you have a electric vehicle, the component was not there earlier, but today it is available. So if you see that way, so we do have a lot of rooftop solars today, and that creates a microgrid within a distribution system. And that system where we communicate to the different components of renewable energy sources from time to time, loads, as well as to the distribution companies. And if you communicate along with accommodating generations with loads, then your network is slightly different than a conventional distribution system. And that new distribution system is named as smart grid as in today's terms. So smart grid networks is basically utilities are poised to move from the traditional power system to a highly flexible, secure and green power system by using integrated communication and advanced control technology. So we want, imagine you have a huge academic campus, for an example, MNIT Jaipur, where we have actually load requirement of actually 3 megawatt, and you have, let's say, 500 kilowatt of actually solar, and rest of the energy is coming from actually the main grid. So we need to understand how to utilize those renewable energy efficiently before bringing power from the main grid. Okay, so the difference between the energy available and energy requirement need to be purchased from the external grid. And if you have a battery, then probably you need to optimize what time the battery need to be charged and what time it need to be discharged. So you need to have an advanced control technology, as well as you have to speak to the grid frequently. There is a communication system between both the sides. In the past, the system was not like this. It is a very steady conventional system. So your conventional distribution system having advanced control technologies and having the capacity of communicating to different components, then probably that type of distribution system can be named as smart grid networks. So there are 4 R's people talk about in case of smart grid. It has to be a distribution system which is resilient, reliable, robust, and reconfigurable. So if you can achieve those 4 targets, so probably your distribution system become smarter. So smart grid is an advanced power system network having two-way digital as well as electrical power flows, capable of self-healing and adaptive, resilient and sustainable with foresight of prediction under different uncertainties. It is equipped for interoperability with present and future standard of components, devices and systems that are cyber secure against malicious attack. And that is how actually we prepare ourselves to have our distribution system in future in such a manner that we can make our system more resilient compared to previous conventional static systems. So what makes your distribution grid smarter? So it is basically the digital technology that allows for two-way communication between the utility and its customers. So in the past, customers cannot speak to utility. Utility never speak to customers. But today it is expected that both talk to each other in a very frequent way. And the sensing along the transmission line is what makes the grid smarter. So do you mean that in the past we had the systems which are not smart? I think they were equally smart, but today the technology embedded distribution systems, automated functionalities that makes your distribution system more smarter compared to the previous practices. Now, as per the customer's perspective, if you already manage activities such as personal banking from your home computer, we say my mechanism of finances become smart. But if you can do the same thing, you can buy electricity. I mean, to be very honest, today we can buy energy blocks to your apartment through a company by paying some money through your internet or online computers. So probably to me, this is a very smart way of managing your electricity systems or energy systems, and that makes my system smarter. Customers will no longer have to wait for monthly statements to know how much electricity he or she uses. With a smarter grid, he can have a clear and timely picture of it. They are smart meters. Can able to see how much electricity you use, when you have to use, what is the cost of energy. For example, if you have a smart meter, and also it talks about the time of use prices, means sometime it is cheaper and sometime it is costlier. If my electric meter which is available to me in my residence also displays the cost of energy that I am consuming at that point of time, so probably I may not be using costly electricity for a non-warranted devices, okay, or not which is not very important or emergent to me. Probably I'll avoid using those machines if the energy cost is very high. So probably that is how customers believe the life has to be. For an example, also the equipments like washing machine is expected to have smart sensors which can sense from the smart meter the cost of electricity and operate naturally. Similarly, your electric vehicles will sense the smart meters costing the price of electricity at a given time and allow your electric vehicle to charge. So these are the dream objectives that all the customers of this country expected to see through these modern distribution systems. So this is a kind of a representative diagram of smart grid. As you could see, generation, transmission, distribution, customer participation, operation, market and service providers. And there are different definitions, but one definition that really, I love it actually. For example, a smart grid is an electricity network that can intelligently integrate the actions of all the users connected to its generators, consumers, and those that do both in order to efficiently deliver sustainable, economic, and secure electricity supplies. A smart grid employs innovative products and service together with intelligent monitoring, control, communication, and self-healing technologies too. That means when there is a failure, we must come back to the original system very quickly. And if you have technology for that, to me, that is smart grid. There are many definitions, so I expect everyone to read many more literatures to understand more about smart grid approaches. And there is one more definition by US Department of Energy. It says that Grid 2030 envisions a fully automatic power delivery network that monitors and controls every customer and node, ensuring two-way flow of information and electricity between the power plant and the appliances and all points in between. So that means, as I told you, my electric vehicle to the distribution company, they are connected through a a specific approach. So if they are connected, they talk to each other and they share their technology and they share their information, get the energy charge at a cheaper cost. So to me, that is smarter. Now, more efficient transmission of electricity, quicker restoration of electricity after power disturbances, and also it reduces operation and management cost of utilities. Now, very importantly, it is expected through a modern distribution grid, we can reduce peak demand, which will also help the lower electricity rates. Probably, I'd just like to explain you, by reducing the peak load, what happens, if for example, this is my peak, and because the energy, the area of cross section that you cannot reduce, because either you use it at 6 p.m. or at 8 p.m. because your pattern of consumption is same. So if I do another characteristic, for an example, if I do this way, all right. So both the areas are same because this characteristic area and the characteristic of that area is same. All right. So the question is those areas being shifted to these new areas, okay? By doing so, I have reduced my peak from x1 to this point, which is x2. So when you reduce your peak, that means the installation capacity of this country need not be increased in next 4 to 5 years, even though there is energy growth. But if you are not able to reduce your peak, then what will happen? Every time you have to put a lot of generations into a system and the cost of installation will increase. So it is basically by reducing peak demand, you are delaying the investment in other sense. You are saving a lot of money for the nation. Now there is one comparison you can see the conventional power grids and the smart grids. So probably this is about the architecture and then the consumer participations and then generation and storage options, power quality, new product and services, asset optimization, self-healing. So probably you can see the conventional systems do everything. However, the smart grid does much better compared to the conventional grid. So it has a couple of other options that you can do. A better market, so for an example, however, conventional power grid do limited customer focus. And similarly, no self-healing in case of conventional. However, self-healing is there for smart grids. So these are the advantages you can see in case of smart grids. Yeah. So coming to attributes of good power system to me is quality, reliability, stability, economy, and security. So with this note, let me stop here. Thank you very much for your kind attention.